AI is doing some incredible stuff these days, right? It's discovering new medicines, creating unbelievable art, but behind all of that digital magic, there's a very real, very physical problem. AI is generating a massive wave of heat, and honestly, we're running out of ways to stop everything from, well, melting down.
All right, so let's really get into this. The demand for AI computing power, it's just insatiable. It's growing and growing, and it's pushing our current technology to its absolute breaking point when it comes to heat. We are talking about a full-blown heat crisis brewing inside the very data centers that power our digital lives. So take a look at this. It really paints the picture, doesn't it? As the power density of our computers goes up and up, the old-school air cooling methods on the left just stop working. They can't get the heat out fast enough. The power levels we need for modern AI are so extreme, they're literally off the chart for what air cooling can handle. We've hit a wall, and we need a whole new game plan.
And where is all this heat coming from? You guessed it, the chips themselves. A high-end CPU already kicks out up to 500 watts. But the GPUs, man, they're the real engines of AI, and they're now blazing past 800 watts. To put that in perspective, that is literally like having a small microwave oven running on high inside every single server. So if blasting servers with huge amounts of cold air isn't cutting it anymore, what's the answer? Well, it requires us to completely rethink how we deal with heat. And the solution is one that's quickly becoming the only real choice for any serious AI data center: liquid cooling. And here's the thing, it all comes down to some really simple physics. Liquid is up to 3,000 times, let me say that again, 3,000 times more effective at carrying heat away than air. This isn't just a tiny step up, it's a total game changer in cooling power. This image here shows you the perfect before and after. The old way up top is just brute force, blasting tons of air over hot parts. But the liquid cooling method below, it's elegant, it's precise. It uses a small, targeted flow of liquid to suck the heat right off the source. The efficiency gains are just enormous.
You know, the really crucial point here is that this isn't just about stopping meltdowns. It's about a complete system upgrade. With liquid cooling, you get data centers that use way less energy, are practically silent, can be built much, much smaller, and get this, it even lets us capture all that waste heat and use it for something else.
Okay, so how does this stuff actually work? It might sound super futuristic, but it really boils down to two main methods that are being used right now. The first method, and the one you'll see the most, is called cold plate cooling. And honestly, the best way to think about it is like the radiator in your car. It's a perfect analogy. You're not dipping your whole engine in coolant, right? You're just running liquid through it to pull the heat away. And here's what that system looks like. You've got this closed loop of coolant. It flows from a big cooling unit through these pipes and into special sealed cold plates that sit right on top of the hottest chips. The key here is that the liquid never actually touches the electronics. It just sucks up the heat through the metal plate and carries it away to be chilled. Okay, so if cold plates are like a car radiator, this next method is, well, it's like jumping straight into the pool. It's called immersion cooling. And you literally take the entire server, the motherboard, the processors, the whole shebang, and you just sink it into a tank of special fluid. Now, obviously, you can't just use tap water for this. That would be bad. This requires these incredible, highly specialized liquids, often called fluorinated fluids. They are masterpieces of chemical engineering. They can soak up massive amounts of heat without conducting even a tiny spark of electricity, so they're perfectly safe for all the electronics taking a bath in them. So all this new tech, this big switch from air to liquid, it means big, big money. We're talking about a massive economic opportunity. So let's look at the numbers, because they are staggering. Okay, get ready for this one. In 2024 alone, the market in China for just liquid-cooled servers is expected to hit nearly $24 billion. And let me be clear, that's not some far-off prediction for the whole world. That's just one country's market this year. But it's the speed of the growth that's just mind-blowing. The market is projected to grow at a compound rate of almost 47% a year. What does that mean? It means the market is on track to nearly double in size about every year and a half. That is absolutely explosive. So what happens when you have that kind of insane growth? Well, you get a market that's forecasted to hit a staggering $162 billion by 2029. We're watching a niche technology become a pillar of the entire tech industry in just a handful of years. And get this, there's even some high-stakes business drama stirring the pot. 3M, one of the biggest suppliers of those special coolants, just announced they're getting out of the business. That has created a huge vacuum in the market and a golden opportunity for new companies to jump in and grab a piece of the action.
Now, this boom isn't just happening on its own. It's being supercharged by government policies. All around the world, governments are demanding better energy efficiency from data centers. They set these targets for something called PUE, power usage effectiveness. All you need to know is a lower number is better, and the new targets are so tough that they're pretty much impossible to hit without advanced liquid cooling.
So where's this all headed? Well, this goes way beyond just data centers. This technology is about to become a critical piece of the puzzle for the next wave of innovation pretty much everywhere. We're already seeing liquid cooling pop up in everything. The 5G towers that give you your cell signal, the battery packs in electric vehicles, the lightning-fast servers that run our financial markets. All of them generate a ton of heat, and they're all starting to turn to liquid to stay cool and run efficiently. So here's the bottom line. Liquid cooling is no longer some niche component. It's now a fundamental, essential piece of infrastructure. Without these advanced cooling systems, the progress we're all expecting in AI, in 5G, in electric cars, it would all literally overheat and just grind to a halt. And that kind of leaves you with one last, really interesting thought. As we race to build these incredible digital minds of the future, maybe our biggest challenge isn't about the code or the algorithms at all. Maybe it's a much more physical problem. Just figuring out how to keep the whole thing from catching fire.